Hello, have you ever wondered how all of those sorting animations you see on YouTube work? Well, in this episode, we are going to build our own sorting visualization app using C++ and the simple and fast multimedia library. The core concept is that while the sorting algorithm runs, we save each swap and each comparison to an array. And then, with a short delay, we apply all of those actions. So let's get started. Okay, so we are going to need one class. I'm going to call it the sorter, to be the source file, and this is going to be the header file. We'll use this class to draw our array on the screen as columns based on the number value, and this class will also hold all of the sorting algorithms. So let's declare class sorter inherits from the SF drawable. Let's also include SFML /graphics.hppp. Okay, now let's start with the constructor. The first argument is going to be the array size. The second one is going to be the window size that we are drawing on. The next is going to be the sounds we are going to play while the algorithm runs. Let's also include SFML/audio.hppp. And here I'm going to also declare a struct called sounds that will hold the sound for a swap and the sound for a compare action. Next, let's create a randomize function that is going to randomize all of the numbers in our numbers array that we will declare shortly. Standard, vector, and numbers. So let's include the vector library. Next, we also need a function that is going to reset all of the vertices. We'll use the vertex array to draw all of our numbers on the screen, represented as columns. Let's also add the window size and the sounds. We're also going to need the column width and the column height, and we will have to calculate an offset based on the window size to center our columns. Oh, and we also have to override the draw function. Alright, for now, this should be enough. Okay, let's go to the source file. I need to include the sorter header. Next, let's declare the static fields. I would like the column width to be 10 and the column height to be 10 as well. Okay, now the constructor. Let's just copy that, and in the initialization list, let's initialize the vector with just zeros. Okay, and the numbers vertices should be of type primitive triangles. Well, SFML removed the ability to use quads, so we'll have to just use two triangles to represent a square. Triangles. The size should be size times 6, because, well, two triangles is 6 corners. Okay, let's also initialize window size and sounds. Nice. Okay, I would like our array to have all the numbers from 1 to size. So let's do a simple for loop that's going to set numbers I to I plus 1. Because, well, we don't want the height to be 0. Next, I would like to shuffle this array or randomize it, whatever. And I would also like the vertices to be reset. And let's also set the offset. Okay, next, the randomize function. So void sorter randomize. We need a helper function that is going to select a random number from min to max. And to do that, I'm going to paste this simple helper function. Let's also include the random header. So now in the randomize function, for int y equals 0, when it is smaller than numbers.size, increment I. Now let's select a random position from 0 to numbers.size minus 1, because this is going to be, well, the position in the array. Now let's just swap the numbers I and the numbers random pause. Okay, quick interruption here. Please just use the I and random pause indexes instead of the actual values from the array. Let's also create a helper swap function. I'm just going to make this private a b. Okay, that should do the trick. So before we draw this on the screen, we have to set our vertices. So void sorter reset vertices. Now for and y equals 0, when I is smaller than numbers.size, let's increment I. Now I'm going to calculate the y position or the height of the column from numbers I. Let's also declare that function float value to y pause, and this is going to take a float value. So here, it's sorter value to y pause value. Sorry, not void, float. Let's return the window size y minus the column height times value minus the y offset. So the coordinates go from the top left corner of the screen, and this basically sets the top to be, well, the column height from the bottom, but we also want to make it more in the center. So that's why I removed the y offset here. Next, let's declare the corners of our column. So the top left corner, the top right corner, the bottom left corner, and the bottom right corner. Okay, next, let's move all of those coordinates by an x offset to make them appear at the middle. Next, I would like to declare the first triangle of our column. So to do that, we have to access the I times 6 plus 0 at the position and set it to the top left corner. I added this plus 0 for clarity, because here I would like the second element of our triangle to be top right, and the third to be the bottom right. You'll see why I did that in a second. Well, the second triangle is going to be like so. Top left, the bottom left, and the bottom right. Okay, and last but not least, let's set the color of those columns to be white. Okay, and finally, let's draw this on the screen. Nice. Okay, now I would like to go back to our main.cpp file, and here let's declare our window and the sorter object. So first, let's declare the width and the height. Next, also I'd like to have those values as a float already. And let's create the window. Okay, just like that. So this is the size, the title, and the style, well, default. Okay, let's declare one more constant. It will be sorter size. I'm going to set that to 50. And let's do sorter. Oops. And we also include the header. Sorter.h. Its size is going to be sorter size. The window size as well with underscore f and height underscore f. And let's also pass the sounds. I'm going to use only one sound, but for the compare, I would like this to be a bit quieter. So include SFML /audio, and now create the sounds struct. Okay, nice. Now, while the window is open, let's parse the closing event. Okay, just like that. Now I would like to clear the window and then draw our sorter and display. Okay, let's see how that looks. Oh, I'm sorry. This should be just I and a random pause. My bad. Okay, let's see how it looks. You have an array visualized as, well, some columns. They're going to be different every time we run the application. Nice. Okay, so now I'm going to create two functions, actually three, the restart function, the update function, which will take the delta time, as well as a simple bubble sort, just for now. Nice. So first let's implement a simple bubble sort. This will be our first algorithm, because it's probably the simplest. Well, in bubble sort, the highest value automatically bubbles to the top of the array. So let's declare a simple for loop and a simple second for loop that goes until numbers.size minus I minus 1, and let's increment j. And now if the numbers j is higher than numbers j plus 1, let's swap j and j plus 1. Okay, that should be pretty much it. Let's see how this looks if we run sorter.bubblesort. And let's reset our vertices to match the values from the numbers array. Nice, the array is sorted, so we can see that the bubble sort algorithm works. I would like this to be animated in a nice way. First, I'm going to declare an anon called action type, and we will have the swap action, the compare action, the finish action, and the set action. And next, let's do a struct action, which will take the position of the first number, the second number, and the action type. Now, let's declare the actions vector and the finish actions vector. Well, the finish actions will be just that nice animation at the end that goes from left to right to check if the array is sorted. Well, this is going to show all of the compare, show, or set operations. Okay, and we have to keep the track of those actions. So I'm going to declare 6 more fields. This will track the current action. This will clear the previous action and set the columns back to white, and this is going to animate the ending sequence. And here we are going to count the comparisons and the swaps as well. Okay, so let's do the update function. So first, let's decrement the next action cooldown by delta time. Oops, and of course I forgot to declare it. Float next action cooldown equals 0.05f. Now, if the cooldown is greater than 0, I'm going to simply return. And if it is not, the function continues. Let's reset the cooldown. Now, if the current action is greater than actions.size, let's also return. Now, let's get the first number that we, did some operation on, and the second number. And now, in a switch statement, we will handle those actions. So first, let's do action type compare. So for int I equals 0, I is smaller than 6, let's do I++. Numbers vertices I1 times 6 plus plus I dot color equals, for example, maybe green. Let's do the same for the second number. Let's play the compare sound. Also have to increment the comparisons here. Let's break this case. And at the end of our function, let's add to the current action counter. In the bubble sort function, I would like to register an action here because we compare this element and this element. And also I would like to create a swap action here. Okay, so before we continue, let's call window.update delta time here. We also have to get the delta time. So to do that, we have to use the SFML clock. So clock, my clock. And at the end of the window loop, let's restart the delta time. And here I meant to do sorter.update. I'm sorry. Okay, let's see if this does anything, or if it breaks. Okay, we see all of the well, comparisons, but this is not swapped in any way. So let's create another case. Case action type swap. Let's do break. So here I would like to swap the first column height and the second column height. So we have to iterate through all of the vertices. We need to declare a temporary y variable. And here, let's do numbers vertices 1 times 6 plus 1 dot, sorry, 6 plus I dot position dot I equals numbers vertices I2 times 6 plus I dot position dot Y. And here, let's set the temporary Y variable. Let's also set the colors. Let's increment swaps. I'm going to display the comparisons and the swaps later. And let's play a sound. Let's see. Okay, that went horribly wrong, because I did one here and I should do I here. Let's see again. And now we can see that the highest column bubbles to the top. Well, but now everything is green and I don't really like that. I would like just to set the color of the most recent actions. So at the top, here before this if statement, we have to create another if current action, for example, is greater than 10, because I want only 10 last actions to be visible, and the clear action is smaller than actions with size. Let's get the position of the columns that we want to reset, and let's set the color to white, like this and like this. And now let's also increment the clear action. And I'm going to also add another if statement. If the clear action is greater or equal than actions.size, set the finish to true. We'll use this flag later to display the finish animation. Nice. But this will take quite a while. So I'm going to simply increase this and decrease the size of our sorter, for example, to just 10. Let's see now. Nice. So now I would like this nice finishing animation that plays if the array is already sorted. Okay, don't... You did not see that. So here, in the update function yet again, if the animation is finished and the finish action is smaller than finish actions.size, let's get the position of our columns, and let's apply the magenta color to all of the corners and increment finish action. Also have to populate the finish actions vector. To do that, in our constructor here, I'm going to simply do finish actions dot push underscore back I, and action type finish. Okay, let's see. Beautiful. Just what we want. Okay, so now that we have that working, let's implement the remaining sorting algorithms, and also let's add the ability for the user to decide which algorithm they want to choose, and let's do some decorations. So, first I would like to create the getters and the setters for the swaps and comparisons. So here, let's do int sorter get comparisons, return the comparisons. Let's also do int sorter get swaps, and return the swaps. Nice. Now, in the main.cpp, I'm going to import the font like this, and let's create a text called bubble sort for now. Let's set the fill color, the character size, and the text bounds, and we have to center our text just like this, for example. Okay, now let's here display the text. So window draw text. Okay, nice. Bubble sort. Now in the event loop here, I would like to create a statement. I would like to select the sorting algorithm. Now here in the event loop, I would like to select the sorting algorithm. Let's switch the key pressed scan code. First case, num1. Well, if the num is 1, let's just use the bubble sort algorithm. And let's restart as well. I'm going to simply copy everything here, to be honest. 2, 3, 5. Okay. Now num2, num3, num4, and num5. So after all of those changes here, we'll have to recenter the text because the words can have different lengths. Oops, I'm sorry. This should be like here. And let's copy that to every case. Nice. So the second one will be selection sort. The third one is going to be insertion sort. The fourth one is going to be quick sort. Here. And the last one will be merge sort. Well, the quick sort is a recursive algorithm. It's going to have some inputs. And so is the merge sort algorithm. Well, and the selection and the insertion are most commonly implemented as iterative algorithms. Okay, let's also do the restart function and the other sorting functions. So void restart, sorter, colon restart. Okay, and in the restart method, I'm going to set the actions to 0, the finished flag to false, set the comparisons and the swaps also to be 0, and I'm going to, well, clear the actions vector, randomize everything, and draw it again, like so. Okay, so the second simplest algorithm is the selection sort. Now the selection sort chooses the smallest number in the remaining unsorted part of the array and then sets it the beginning of it. So let's do for int min equals I. This will be our the index of the smallest number. Now for int j equals I plus 1 if the number j is smaller than the number at min, select the set the min to j. Okay, and let's also swap this after the second for loop. Okay, now we can push to our actions the swap action and the compare action, for example here. So actions dot push back j min, so j min action type compare. Okay, so now if I click 2, this should work. Oops. Okay, let's also declare just for now empty bodies of the other sorting algorithms. So insertion sort, the quick sort, and the merge sort. This should be our. As you can see, this goes to the end of the array, and then sets the smallest number at the beginning here. Nice. Now if I click 3 or 4 or 5, nothing happens. Okay, I'm sorry, let's keep the height to 0 here. For some reason this goes down. I do not want that. Okay. Here I'm also going to set this to 0. Okay, let's maybe increase the sorter size to 15. I would also like to display the comparisons text and the swaps text. So here, let's create comparisons text. Let's set the character size to be 48. And let's set the position to be centered. We also need the global bounds, the comparisons text. Let's do the same for the swaps text. Now let's display this. So window, .display, .draw, comparisons, swaps. Also, I'm going to do a simple, cheesy kind of way to update those numbers. I'm going to create a string called as comparisons. Now, I'm going to append at the beginning here a string of length 6 minus a string comparisons dot length and set the values to be 0 plus string comparisons. And let's set the comparisons text to be comparisons plus as comparisons. And as you can see, this goes up. Nice. Let's do the same for the swaps text. So I'm going to just copy that, paste it here. Name it the comparisons here to swaps. Yeah, swaps. Okay, let's check that out. Oops, this should be swaps text. Here, as you can see, well, we have less swaps than in the bubble sort, because we only swap once in the first loop. But in the bubble sort, we use the swap operation quite a lot. Great. Okay, so now the only thing left to do is to also add the insertion sort, the quick sort, and the merge sort algorithms. So let's start with insertion sort. Insertion sort moves the element back to its appropriate place from the beginning. Well, we'll see how it looks in a second anyway. So first, the outer loop, next the inner loop. Now we start from I, and while the j is greater than 0, we decrement j. And here, if the numbers j is smaller than j minus 1, we swap j and j minus 1, and else if it is not smaller, well, we just use the break operation, because the element is in its place already. And that's the whole algorithm. So let's also push back the actions. So push back j minus 1, action type is compare. And here, let's push the j and j minus 1, but the action type is swap. Like this. Let's see if this works. And as you can see, this is how the insertion sort algorithm works. It inserts the elements it finds Well, in the appropriate place here. Great. Now the two more complicated algorithms are the quicksort and the merge sort. Well, for the quicksort, we have to define a helper function called partition. So let's do void partition. It has two arguments, the L, which stands for low, and high. Now, let's implement the partition method. So first, we have to get the pivot. Well, and the quicksort algorithm basically makes all of the elements left to the pivot smaller than the pivot, and the right of the pivot larger than it, and then recursively applies it across the whole array. Okay, so for j equals low, while j is smaller than h, let's increment j. Now, if numbers j is smaller than the pivot, let's increment I, and let's swap I and j. And here, after the for loop, let's swap I plus 1 and the h. Let's return I plus 1. I'm sorry, this should be an integer, of course. Let's change that here as well. Nice. So at the here, let's do so actions that push back j and h, because we compare j to our pivot, which is declared here, and the action type should be compared. Okay, and here before the swap, we have to do the same but push back the action type swap, as well as the end here, actions that push back I plus 1 h and action type swap, because we swap these two values. Okay, now here we have to do basically if the L is greater or equal than right, let's return the partition index. Should be a partition. Let's get the L and the right here. And now we recursively apply the quicksort across the whole array. Okay, let's see if this works. Okay, I broke something. Oh, the problem is here. We should increment j, not h. I'm sorry. Let's see now. Nice. You can see that the array here is getting sorted a bit faster than using the normal selection sort or the bubble sort. Okay, the last algorithm that I would like to cover is the merge sort algorithm. Well, for merge sort, we need to implement one more helper function that will be called merge. And this function is going to merge basically two sorted sub-arrays inside our numbers array. So let's create the merge function. L, the middle, and the right. Okay, so first we have to create the sub-arrays. So to do that, let's create two standard vectors, and now we have to populate them. So now, for I, when it is smaller than n1, let's set the left vector to the numbers L plus I, and now let's populate the right subarray. Okay, nice. Now we have to declare a few variables, the I, the j, and the k. So the k variable is the number is the index that we are currently merging to. The I is the left array index, and the j is the right array index. While I is smaller than n1 and j is smaller than n2, if the current left number is smaller than the right. Let's set numbers k to li, and let's increment I. Else, let's set the number to the current number in the right array, and let's increment the right array counter. And regardless of the outcome, let's implement k. Okay, so now, well, one of those subarrays could still be unfinished. So while I is smaller than 1, set the numbers k to l left array I and increment both those values. And next, while j is smaller than n2, let's finish the numbers from the right array. Okay, now we have to add the actions. Well, so here this if statement is quite simple. Let's just push back the l plus 1, the m plus 1 plus j. I'm sorry, this should be l plus I. Nice. Okay, but now we don't want to use the swap. We want to use the set action. Because, well, if we swap this, the merge sort does not work. So let's do set here, the set action here, and now also in this loop and in this loop. Okay, that should be it for the merge function. Now let's do the merge sort. Now similarly, if L is greater than the high, I'm going to return R. Okay, if left is greater than the right, let's return. Let's find the middle index. And now let's just merge sort from left to mid and from mid to right. And after this, we have to merge the two subarrays. Okay, before I run the program, there's one more thing we have to do. And that is to kind of modify the update function. Well, now I made it so that the pos2 is not the index, but the actual value that we want to replace the pos1 with. So here, let's do case action type set. And let's do break. Now I'm going to calculate the y pos from I2, and I'm going to replace the top parameters with that value. Let's also change the color to a greener one, and let's play the swap sound. Actually, I'm also going to increment the swaps value just for simplicity, so I don't want to display a third parameter in the application. And the last thing, if the action type here was actually set, I don't want to change the color of the second argument. If that makes sense. Okay, let's see. Okay, something didn't work. Oh, here I forgot to push this action, and instead I declared. Okay, sorry for that error. Let's see now if the merge function displays properly. Okay, well, it works, but for some reasons the triangles do not align properly. Because here I do +0 instead of +I. Okay, that should well fix this problem. Perfect, the merge sort completed successfully. Let's see this on a larger scale. So for example, let's do sorter size 200, and let's set the size to be just 2. Okay, let's see if this works. Well, bubble sort is quite slow, obviously. Let's switch to merge sort. Here you can see that slowly but surely the merge sort algorithm, well, sorts the array. Obviously, the array is already sorted. Now we just modify the columns that are drawn on the screen. And as we can see, the array is now sorted. So, that would be it for this episode. Thank you so much for watching. Please leave a like, share, comment or subscribe. And see you next time. Goodbye.